Hello dear students, welcome back to this video lecture series. I am Chetan Rajoria from ABES Engineering College Ghaziabad, and I am taking up unit number 1 of the subject Fundamentals of Mechanical Engineering. The subject code is BME 101 or BME 201. So before this lecture we discussed different fundamental concepts of stresses and strains as well as modulus of elasticities. We also discussed different cases of stress strain diagrams, like the stress strain diagram for ductile materials, for brittle materials, as well as for mild steel. Now, in this lecture, we are going to discuss the method to find the net elongation of a bar having varying cross sections. We will also discuss the method of superposition to find the net elongation of a bar having different cross sections, or the cross sections may be same also, but there may be some internal forces along the length of a given beam. So this is the overall topic of this lecture, and let's come to the point directly. First of all, we are going to discuss what is the method to find the elongation of a given bar having a constant cross section. Suppose there is a bar having round cross section, circular cross section, and it is subjected to a tensile load of F newtons. Okay, the initial length of the bar is L, and due to this axial tensile force, the length of the bar is changed to a new value of L plus delta L. So this is the elongation of this bar under the action of this tensile force, delta L. So what is the value of stress? Stress can be written as force upon cross-sectional area. Suppose the initial cross-section area is A. So F upon A is the stress, and strain epsilon can be written as change in length upon original length. So if we divide these two values, we will find the value of Young's modulus. So Young's modulus, capital E, is equal to stress upon strain. That is, E is equal to F upon A upon delta L upon L is equal to F upon A into L upon delta L. From this, we can calculate the value of elongation. Delta L is equal to F into L upon A into E. Using this formula, we can calculate the net elongation of this bar. It's not necessary that the type of force is always tensile. It's not like that. The nature of the force may be compressive also. In case of compressive force, the delta L will provide you the value of contraction in length instead of elongation. So the same formula is used for the calculation of elongation as well as for contraction. So this formula is applicable when there is a constant cross section for a given bar, means a cylindrical type of bar. For that case, we can use this formula for the calculation of elongation. But what to do when there is some variable cross sections or different cross sections over the length of a bar? Let's take an example. This is the bar AB, BC, and CD. In this bar, you can see there are three different cross sections. The largest cross section is within the portion AB, intermediate cross section is between BC, and smallest cross section is between CD. So in that case, we will use this formula 3 times. We generally use this formula as number of times as there are different segments of a given beam. So in this case, in this particular case, we will use this formula 3 times, and we will find separate elongations for the portion AB, BC, and CD. And then we will find the net elongation using the method of superposition. So what is method of superposition? Superposition method states that the net elongation of a given bar is equal to the algebraic sum of elongations of individual segments of that bar. Means delta L AB plus delta L BC plus delta L CD. This method of calculation of the net elongation is called superposition method. So any one of these values or more than one values may be negative also. It means that if suppose BC is under the action of a compressive nature of force, in that case delta L BC will be negative. So one or more than one parts of this summation may be negative. So this is called superposition method. It is a widely used method for the calculation of net elongation of a bar which is having different cross sections over its entire length. So we will take an example or numerical problem based on this same case. So let us see what is the problem. We are coming to the problem directly. So students, please read out this problem very carefully. Calculation of elongation of an axially stressed bar using superposition method. So this is the bar having different cross sections. You can see in this question, there are three segments AB, BC and CD. The portion AB is having the length of 0.75 meter. Portion BC is having the length of 1 meter and portion CD is having a length of 1.2 meters. The cross-section areas of AB, BC and CD are also given in this question. Okay, so what we need to do? We will calculate the net elongation of this bar using superposition method. And first of all, we need to find what is the total value of P3, because out of these four forces in the question, P1, P2, P3 and P4, three forces are given and one force is not given. Okay, it is unknown. So let's read out the question carefully first of all. A member ABCD is subjected to point loads P1, P2, P3 and P4 as shown in the figure. Okay, so P1 is acting on the extreme left end of this beam of this rod. The value is 120 kilonewton, P2 is 220 kilonewton and P4 is 160 kilonewton. We do not know the value of P3. So using the method of equilibrium, we will calculate first of all the value of P3. So let's calculate the value of P3. Look at this diagram. P1 is towards left. We will take it negative, and P2 and P4 are towards right. We will take these two forces as positive. So let's write the expression of the net summation of forces along the x-axis or along the horizontal direction. So minus P1 plus P2 minus P3 plus P4. Look at this diagram once again. P1 and P3 are negative, acting to the left hand side. P2 and P4 are positive, acting to the right hand side. So P1 minus P1 plus P2 minus P3 plus P4 is equal to 0. Let's put the value. So P1 is 120 minus 120 plus P2 is 220 minus P3, which is unknown, plus P4. The value of P4 is 160. 160 is equal to 0. Using this expression, we can calculate the value of P3. P3 is coming to be 260 kilonewtons. So this is the value of P3. Now, before applying the method of superposition, we will find what is the net force which is being transferred into these three members. Suppose this member is first one, this is the second one, and this one is the third one. We will draw the individual free body diagrams of these three portions of the beam. So first member, AB. For AB part, look at this diagram. There is a force of P1, that is 120 kilonewton, acting to the left hand side. 120 kilonewton. So clearly, for balancing this portion of the beam, there must be equal and opposite force acting to the extreme right hand side of this portion. So it should be 120 kilonewton. So this is the free body diagram of the first segment of this beam, AB. Now let's try to draw the free body diagram of the middle portion, BC. Okay. Now, please observe that we need to calculate that amount of force out of P2 which is acting on the central portion only. We have already calculated or already used some of the amount of force P2 in the first part, that is AB. It was 120. And what is the value of P2? Look at this question. P2 is 220. So please observe this carefully. For calculation of the force which is acting on the middle portion, what we need to do, we will assume a imaginary line passing through this junction B. Okay, an imaginary line passing through this junction B, and we will add up the forces which are acting to the left hand side of this imaginary line AB, including this force P2. So to the left hand side of this line, there are two forces, P1 and P2. Let's add up these two values as per their directions. So P1 is acting to the left. Let's take it negative. P1 is minus 120 and P2, it is 220. So the addition of these two will give you the value of 100 to the right hand side. So this force is 100 kilonewton to the right hand side. That is, it is a compressive type of force because arrowhead is in contact with this junction. It is towards this junction. Therefore, it is a compressive type of force. Now let's check the force which is acting on this junction C. For calculating the amount of force which is acting on this side of the central portion BC, what we need to do, please be very careful about this. On this junction, we will draw an imaginary line passing at exactly at this location on the junction C. And we will add up these two forces, P3 and P4, as per their signs. Okay. All the forces will be considered which are acting to the right hand side of this line, including this force P3 also, because it is acting on the same line. So we need to consider only these two forces, P3 and P4. So what is the value of P3? We already calculated that P3 is equal to 260 kilonewtons acting to the left. So let's calculate the value. Minus 260 plus P4. What is the value of P4? It is 160. So minus 260 acting to the left, P3 plus P4, that is 160. The value or the net sum is minus 100. Minus 100 indicates left hand side direction. So it is 100 kilonewton acting to the left hand side. So in this way, we have drawn the free body diagram of the middle portion of this beam. Okay, this is called a redistribution of forces. At this junction, the net force is P2, which is 220 kilonewton. Out of these 220 kilonewtons, some portion will be transferred to the first part and the remaining portion will be transferred to the central part. Okay, so the total amount of force which is acting on this junction B is 220 kilonewton. Out of this 220 kilonewton, 120 kilonewton has been utilized by the first part for its elongation, and the remaining portion or remaining amount of force is utilized by the central portion. Okay, so the value is 100 kilonewton. So in this way, 120 plus 100, that is 220 kilonewtons, which is acting on this junction B. Similarly, at this junction, junction C, the total amount of force which is acting is P3, which is equal to 260 kilonewtons. Out of this 260 kilonewton, 100 kilonewton is utilized by the central portion and remaining 160 will be utilized by the third portion. Let's see what is the total amount of force on the third portion, CD. Okay, so on the right hand side of this portion, the force which is acting is P4. The value is 160 to the right. Sorry, 160 kilonewton. So obviously, on the other end of this portion, third, there must be equal and opposite force of 160 kilonewton for individual balancing. Please remember that if the total beam is under equilibrium, under static equilibrium, in that case, the individual segments, the individual portions of the beam will also be in static equilibrium. So AB is in equilibrium, BC is also in equilibrium, and CD is also in equilibrium, that is static equilibrium. So in this way, we have calculated the net forces which are acting on these three portions of this beam. Now let's apply the formula of elongation 3 times. So net elongation of the bar AB, it is a tensile nature of force. The value is FL upon AB, AE. We will use this formula. The force is 120, 10 to the power 3 kilonewton. The length, what is the length of AB? The length of AB is, this is the area. Length of AB is 0.75 meter. 0.75. F into L upon area. What is the cross-section area of AB? Area of AB part is 1600 millimeter square. I'm converting this value, which was given in meter, into millimeters for keeping the same units in the whole expression. So I'm using the unit of force as Newton and unit of length as millimeter. So 0.75 into 10 to the power 3, it will give you the value of length in millimeter upon 1600 millimeter square into E. Value of E is given 200 gigapascal. We will convert this value into megapascal because 1 megapascal is equivalent to 1 Newton per millimeter square. And we are using these two units, Newton and millimeter, for force and length. So we will convert this value gigapascal into megapascal by multiplying this value by 10 raised to the power 3. 200 into 10 raised to the power 3. Okay, so in this way, we can calculate the net elongation of the effective elongation of the portion AB. Now, BC is under the compressive nature of force. The arrowheads are acting inwards. It will reduce the length of the portion BC. So it must be negative. Delta L BC is equal to, I will use the same formula once again, FL upon AE. So 100 into 10 raised to the power 3 FL. What is the length of this middle portion? The length of the middle portion is 1 meters. So I will write 1 meter as 1000 millimeter. FL upon A. What is the area of the central portion? Area of the central portion, BC part, is 625 millimeter square into E. Gigapascal has been converted into megapascal. So this is the elongation. We should say it is the contraction of the central portion BC. Okay, it should be negative. I'm writing this value with minus sign. What is the net elongation of the third part? Delta LCD is equal to F, which is 160, 10 raised to the power 3, multiplied by L. What is the length of this portion? The length of this portion is 1.2 meters. That is 1200 millimeter. FL upon area. What is the area of this part? Area of CD part is 900 millimeter square. 900 multiplied by E. 200 into 10 raised to the power 3 megapascal. So in this way, we can calculate these three different elongations or contractions of these three segments of the bar. So the first value, that is the elongation of AB part, is 0.281 millimeter by calculation. The contraction of the middle part is equal to 0.8 millimeter. Okay, I'm using minus sign because this portion is under compression. And the elongation of the third part CD is 1.0667 millimeter. Okay, so these are the three elongation or contractions of these portions AB, BC and CD. Now let's calculate the net elongation. Delta L is equal to, let's add up these values as per their signs. 0.281 minus 0.8 plus 1.0667. So the value is coming to be 0.54795 millimeter. And that's the answer. Please observe that the net summation is positive, which indicates that the overall change in length is positive, means the overall length of this bar is increasing. Overall, although the central portion is under contraction, but the net effect is elongation because AB and CD part are elongating. And so that is the answer. So this method of calculating the overall elongation is called superposition method. So I hope you could understand the concept of using this method. Okay. That's all for this lecture. Thank you so much, students.